Hi, today we're going to look a little bit on GPS trajectories and how to import GPS trajectories and play around with them to understand how to make sort of space activity spaces and so many other things. So first of all, we're going to start with a map that contains map information about the city of Visby, which is located on Gotland on the Baltic Sea. And this spring and summer, we actually got a few tourists to run around and roam around in the city with GPS trackers on them. The material you're going to see today is completely anonymous, and there's no name, there's no individuals, there's no nothing that could be shared, and all the trajectories are quite sort of similar to all the others. So there's no need to worry about anything being revealed on any basis. It's just sort of where people were moving when they were recorded as tourists a specific day. So in order to do that, we have to transform a very common format kind of thing, which is a GPX, which is the format that you see in very many phones, or you could see it in GPS loggers and many other kinds of things. So in order to do that, we have to import it and search for something using the GPX importation function, and I'm simply going to search for GPX, and I get GPX to features conversion. So if I click this, it takes a little while for the software to open up the thing, and then I can choose where the file is being located, and let me see, I made sure that it's here, and it's here in these locations. So we've got literally 1, 2, 3, 4, 5, 6, 7 files. I'm going to show the first example, and then I'm going to pause the videos and do the other ones. So at some points you'll see that it probably will be one file and then 7 very quickly afterwards, but this is simply to save you time rather than the opposite. So I opened this one up, and in this case I also had the opportunity of saving it into, let me see, 2 seconds, Undervisning, which means education or teaching in Swedish, and out, and then you do have the same kind of a system. So I'll call this one GPS, and I'll go with the number 038 in the end. That will be okay, I think. And I click OK. And we'll think for a little while. You can see the process at the bottom of the line, and there you do have the trajectory is in terms of points. If I right click and go for zoom to layer, we'll see a concentration of where this tourist walked. Just to give you in on a little bit of a secret here, the new vessels, the new cruising ships, were allowed to land in the city starting in 2018, and the big cruising ships are out here, and they are literally that tourists are allowed to go and walk along this route, and then they go into the city and look at different kinds of things, and eventually they're moving backwards or moving back. So if you see this trajectory, it means that they've been walking to the city, and they're walking around in the city. And please, if you like, just Google Visby. It's a really nice medieval walled city, really sort of odd and exotic as far as I'm concerned in the Swedish sense. It's a lovely city, much picturesque things to see, and I'm sure most of the tourists thought the same way. But I'm not here to make sort of I'm not here to sell the place, but rather to look for what we can do about it. So what I'm going to do now is that I'm going to pause a little bit and continue when I've done the remaining GPS trajectories. So after some time, I've imported all the other GPX materials. We now have 7 files in the system. Just to show what it looks like, we do have now VGS84 as the datum of the files. However, the Gotland case and the roads in it are in fact in SWERF 99. So we've got 2 different projections. One sort of longitude and latitude, and one Swedish projection. And in order to do some calculation with things, we do in fact need to transform them into SWERF 99. So as in the previous case, I'm going to do the project for one of the trajectory point lines, and then I'm going to pause the video and do it for all the others. So what I do, I go again to the search windows, and I write project, And project data management is a tool we want to use. So I click on this one and I choose from this one the name of the first, GPS 044. It identifies very quickly VGS-84. And I click, again, let me see, this is where we want to have the things, 44. I don't want to replace it exactly, I want to have it as GPS 044b, and the the coordinate system we want to use in this case, could be others, of course, is the projected one. We do have country bases, let me see, national grids, we do have Sweden, and the very last of these ones, the SWE-Ref 99, not trademark but transverse Mercator, of course. And it has been choosing it, so we can see all the settings, SWE-Ref and VGS-84. So if I click here now, it's going to transform the information. We can see down at the bottom that it's running the transformation, and it has been transformed. So if I right click on this one, it will think for a few seconds, and when it has been sort of finalizing the thinking, it will open up the window here, and it says SWE-Ref 99 transfers Mercator rather than VGS-84, which is good. Now I'm going to pause, and I'm going to do it for all the other files as well. So now I've done the projection of all the files, and I've given them the name 38B, or B at least, for the last ones, and the remaining ones are the ones not having the B, so I can literally sort of right click on these and select them to be removed, and then I only keep the one that has got the new projection. If you're skilled in GIS, you would perfectly well know that there are different kinds of opportunities to do projections more sort of on a batch level. But since this is not what I wanted to do, I can just quickly show you that you've got a tool in geoprocessing where you can look for results. It's a simple batching process where you can double click the previous version. You can just change what you've had as a setting and make the, if you've got a repetitive work but not very much sort of skill in how to make a batched projection or anything else, you can replicate the former procedure and with a limited amount of information or skill needed. So just double click the previous function and you will have a good and much quicker precision. And there are also other kinds of techniques where you can do sort of better batched projections and stuff. I would classically use, for instance, the ARC catalog and stuff. But again, this is not what we're going to teach today. So these are now SWE-Ref 99 on the layer, and also the files and the roads. So the entire system has now been converted to a projected Swedish system. So what we want to do is to look for something where we can transform all these dots into lines. And I'll show you what that means by deselecting the ones not being on my prime interest. So if I zoom in to a subsection here, we could see that this individual has been walking along roads, likely, and perhaps into buildings that are not into the roads. Of course, it could be an open square or anything. And if we move the cursor around, so in fact this is a church, I know that. So the individual has been in the church, been looking at the tourist locations there, and been walking around in the various parts of the city and seeing what it has got to offer. However, dots don't really give you the sense of linearity or the trajectory that it's sort of that it has got. So what we want to do is actually give the idea of how it has been flowing. In order to do that, I will show you something else before, because I'm going to do the right click and open attribute table. And this is what we got in this particular GPS trajectory. We've got the name of the specific file, and we got the date for when it was collected, and also time. So we've got a lot of information. We also got the elevation, so we can see at what altitude in meters the individual was walking at any time. If we move to the very end, we got another kind of system. You'll see very quickly. These are waypoints where the individuals were walking. There's 2,851 points that makes one trajectory. But these ones, in the end, that I've now selected, and some of them will be sort of possible to identify, are things that came with our specific make of the GPS logger, which means that they could press a button to identify specific locations. We asked them to do so for things that they found interesting. So you could see now that the individual has been passing a few buildings, or perhaps a shop or a cafe or something like that, and click the button and see, this is an interesting spot. So what we want to do if we find out a trajectory is that we don't want to have this sorting of the waypoints, no, sort of the points of interest in the end. So what I want to do is in fact to select only the ones not being points of interest, but just the trajectory. So I'm going to clear the selected features. I'm going to go for, let me see if I take this away and I do selection, select by attributes. And now in this case that the type is the variable, so type, and type is not equal to, and then I get the two different values, and they are not equal to the WPT. If I double click this and press OK, all the waypoints are selected, with the exception for the ones being at the bottom that weren't just points of interest. So if we want to make a linear trend of these ones, we want to have the ones that are sort of the linear sense, not the ones that actually are showing something else. So the next step will then be, with the selected ones, to go for point to line, and there's a specific points to line. In fact, there's a specific function for this, so I can click the points to line, and I can choose the input, which in this case is the GPS-038B, and it's going to work with the selected material, so I don't have to go for something else. I don't have to do any other changes. So I'm going to change GPS-038B to L, in this case signifying line, but I'm not going to give anything about the line field or sort field or close line, because I simply want to have sort of a transition from one point to the next in the order of how it happened in the events. So I'm going to press OK, and after some thinking, as you can see at the bottom here, down here, you can see the line has been created. You can't really at the moment, so I have to choose clear selected features. I'm going to take away the dots, and I'm also going to take away the roads, and we can, if I zoom out, see how the individual has been walking, and it follows relatively closely, of course, to where we can see the dots. Again, I'm going to redo this for all the other ones, and you will be returning to me and see what we've been done when all these lines have been finalized. So now all the lines have been created from the dots, and I've deselected all the dots, the point layers, so we are not looking at them, but we could see the trajectories, and it's interesting to see that the tourists seem to be walking fairly similar trajectories where they move in and move out and so many other things. What we want to do in the next step is actually to create polygons of these lines. And the idea and the order of it from an activity space point of view is that we want to create surfaces that represent the area in which the tourists move, and sort of perhaps see that the activity space from within, and which sort of activities like shops and businesses and amenities are accessible for the individuals that are walking. So this is what we want to do with this new technique. So I've already Googled up feature to polygon, because line in this case is a feature, and we're going to make the line into a polygon. And as in the previous cases, I'm going to do with one, and then I'm going to let you return to the case when all the other polygons are ready. So we start with this. I've got input feature, and I put in the line GPS. Let me see, we start with 38. Let me see. Yes, 38 I think is the one we've been working with before. And let me see, the out one here is, and then we have the, let's call it P instead, as GPS-038P, P as in polygon rather than L as in line, of course. I press OK. If I scroll down, I can see that I'm not, in this case, particularly interested in the tolerance levels or anything like that, so I'm just going to press OK and go with the results. We're thinking a little while, and we get here, as you can see, a depiction of the area. Since the individual is walking very closely when it came in and came out, we can't really see the surface, but we can see the area from within the individual was moving. And if I scroll down to this one and zoom in, we could see that it's, let me see even further, in any of these sections, we could see that it follows closely the trajectory of the lines and stuff. We can also see where very many of these individuals have been walking. There must be interesting stuff going on there. So I'll redo this for all the other ones, and you'll return with a more sort of polygon-rich material in a little while. Now, literally, we've got all the material we need to create sort of the activity spaces we want. I've now deselected a few of the areas because the material becomes very, very messy as we've got lots of dots and stuff. But just I'm retaining and keeping this GPS-038 kind of thing, where the first one here is being selected is the dots where the individual has been walking. And if I deselect that one, we can go down to the line. And we can see the green line that is outlining the things, and if we deselect that one, we've got only the area left. It's interesting to note that if you go, for instance, for this one, the GPS-011 instead, we could see a completely different trajectory that this individual has been going, probably in a car, on the main road into the city, and has been walking around in specific areas here, but very close, probably in the same kind of streets, and up to some of the locations. It's all very fascinating in a sense when you can see the areas, but these are the polygons of the other individual of this very day. I zoom out and let me see, zoom back in, so we've got some of the more material running for us. So one of the things we can think of and how to deal with these kinds of things is that the activity spaces could be measured, for instance, in standard deviational ellipses. That means that you take you look for the average location of the individual, and then you have a standard deviation of the distribution of points. And if we go back to this one, the GPS, we've got a distribution of points. We know where the individual has been. So by looking for the standard deviational ellipse, we can generate an idea about how the individual has moved in the city over the day and where the potential areas of interests are. And since in this case the dots are being recorded with sort of a fixed time interval, we don't have to deal with times, because if the individual has moved quicker or slower, it's going to result in more or less points per meter. So the density of points is actually taken into consideration when we are doing the distributional pattern. In order to understand how we can do standard deviation of ellipse, I'm simply going to write standard deviation. I'm going to search for that, and the directional distribution or the standard deviation ellipse is one of the options that turns up. So if I click on this one, I can see the explanation tells me that I've got one pattern and it's trying to understand the distribution in terms of standard deviation. I choose to be consistent the GPS-038b, and I now for the naming GPS-038 STD, I'm going to call the standard deviation ones. We can choose between different standard deviations, so this is just sort of, we want to keep it a little bit slim, so I'm going to go for one standard deviation, which literally is going to say something like 2/3 of the dots are going to be encased, the other ones are being outside. But it of course depends on the distribution. If I click OK, it thinks for a little while. We can see down here on the lower part of the section, and there we go. This is the pink line here is telling us the distribution of the points. So within this area, we've got one way of depicting sort of activity spaces. It's a very useful thing to do if you're running sort of planning strategies or anything like that. If you've got a long range of various kinds of groups, using GPS loggers to have a standard deviation ellipse to see the core area and the distribution of where they usually are. That gives a hint of what kinds of area and what kinds of amenities and services and stuff that are within the area of frequent visits. In this case, it could be done also by having, for instance, spatial joins to or proximity counts to known locations like shops and cafes and the medieval wall and museums and historical and architectural sort of sites and whatnot. This is one way we can deal with the material. Another way of dealing with the material is going from the points patterns to the line pattern. So if we go again for the 38, there it is, the 38 line, and I'm going to take away this one. An equally simple one is to think of activity spaces not as the distribution of points, but rather looking as it from a buffer point of view. And I can go into the classic sort of geoprocessing tool and have a buffer, and I could choose the 38 line. And I'm going to do the same here. I'm going to write GPS-038 buffer. And in this case, I can of course choose what I'm going to do. Since it's a linear unit, I want how much of the meter surrounding it that I want to be buffered. And let's assume that we've got something like 10 or 15 meters surrounding the line to which you could see things in your surrounding, and you could see because they're going to be houses and these kinds of things. So this is the exposure, the area of exposure where you're walking. I'm making sure that since we've got a line, questions sort of as if we're going to dissolve or not is not really important because it's just one line. If you had multiple linear lines or multiple dots, you would really have to think these through. In this case, it doesn't really matter. So I'm going to go with the OK, and after a short while, we're going to generate the buffer. And again, this is the distribution of the urban area and what they see. And if I go back and click and activate the road surface, we could see this is literally where the individual has been walking and the kinds of environment that the individual has been exposed to during the trajectory. This is of course one way of dealing with activity spaces. It can also be seen as a share of the total of the city being experienced at the limited time period. The final one, the minimum convex polygon, is usually where we are trying to create sort of the polygon from it all. And literally, we've already done that in a sense. So if we move back, let me see, I zoom into something and we go for this one and I deselect everything else. Let me see, this is literally the minimum convex polygon for this individual. This is where it has been walking and this is what we've got. So we now got three different ways of looking at activity spaces. The polygon, the distributional, the standard deviation and ellipse, and we do have the buffer, which is here, which unfortunately with the color is almost the same as the other one. So these are three classical ways of depicting activity spaces of an individual. A good way of continuing with this one is to merge all the individuals into one common sort of field and see if we've got a similarity or deviation from this particular individual. For doing that, I'll go for the merge function. I'll Google merge, and it, as you can see, comes up merge data management, and just give you a very hint of how we can do. If I go for the dots, I go for one extra, and so forth and so forth. 95, 01, 77, 44. Yeah, that was it. And I can literally call them points and merge, I guess. I'm afraid I have to redo it again because it's going to be this one, GPS points merged. And I'm going to click OK, and I can look for the things. Since all the variables are the same, of course it's going to be easy to merge them together. And if I click OK, and it thinks for a while, and after a short while we're going to have a combined data set where all the dots from all the 7 trajectories are being illustrated on one of the same levels. And here it comes. These are all the dots that all the individuals have been walking. And of course, the same way as before, which might be interesting and handy, if we transform these, and this is now to be very, very handy in terms of how I work effectively, I'm going to go away and do points to line. So if I take the last points to line and I'm going for the GPS points merged, and I'm going to do GPS line and close, choose OK. We can create one line. In fact, this is not going to make good sense since they may not start and end at the same locations, but it's just to show the technique and how it looks. And if I turn this off and I turn the dots off, we see the complexity of all these lines ending up together. And if I take away the street layer with these are all the lines the individual has been walking. And of course, as in previous cases, if I choose the lines in this case, where have we got it? A GPS line, it's not turning up for some reason. We could have, there it is. We give it the same kind of meters, 15, and I'm not going to do anything with how it would dissolve or anything. I'm just going to click OK. After a short while, we will see how the area now is being covered. This is the area of the city that in fact has been visited by the tourists, or seen by the tourists. And of course, if you again subtract it from the factual city, you can see what areas they visit and which areas they don't. And finally, in the same sense, by combining it or merging it or creating sort of a polygon of it, we could do the outline of these ones and making sure that the combined polygon is in fact what we call the minimum convex polygon. So this is one way of making use of the GPS trajectories that I think is interesting for researching. In this case, in tourism, to understand what kinds of areas they visit, but also, of course, more particularly when it comes to planning for kids in schools or seniors, citizens that are slower in traffic, for instance, or see worse than others. That might be sort of helpful to understand what kinds of an urban landscape we should construct to better fit the individuals that walk in it and live in it. That would be literally everything for me so far, and over and out, and have a good training yourself.